All right, so this is number, where is this thing? Let's see. Okay, so we are working on number 11. Okay, so in the previous video, I did mention there is like 3 ways for you to see a problem first. Ooh, that's not a good color. Okay, first, check if you have only one log in the equation. So meaning if you have an equal sign, you have equal sign. You either have the log here and then nothing here, or you can have nothing here or something there but no log, and then you have the log there. So one log on one side of the equation. So the second one is that you have one log here and then plus something equals one log here. Okay, and so in that case, if you have one log, like log 5x equals log 5x plus 2, 2x plus 2 maybe. Okay, so you have one log here and one log here, then that's great. That's example number 2. An example for the letter A would be like log 5 x equals 3. So you say one log here, no log at all. So that's example, that's type 1, type 2, one log on each type. Number 3 will be maybe multiple logs on each side. Multiple logs on each side. Multiple, at least there's at least one multiple. So it could be like one log here and then equals multiple logs. Or it could be multiple logs on both ends, okay? So looking at this expression right here, you look at your equal sign, how many logs here, and then how many logs in here. And so that's what you need to look, okay? So in that case, which situation is this gonna be? Example 1, A, B, or C. So obviously that's gonna be this type, right? So that's, and if I give you another example, let's say log 5, 3x equals log 5, 2 plus log 5, 3. Okay, so this is one log, multiple logs, so that will be 3. Okay, I mean C. If you have log 2x plus log 2y equals log 2x minus log 3x. Okay, how many logs here? You have 2 logs, you have 2 logs. So again, that's still situation 3. Okay, so this is basically situation 1. If you have situation 1, then change this to exponential to be able to solve it. Okay, change it to exponential form. Okay, so I'm gonna give you a different example similar to that. Okay, so log 5, 3x plus 2 equals 3. So if you want to change this one to exponential, it will be, you start with the base. So that's going to be 5 to the power of 3, base, exponent, argument. Okay, so base, exponent equals the argument. So 3x plus 2. So now you can simplify this. So that's 5 cubed. That's going to be 125 equals 3x plus 2. You subtract 2, 123 equals 3x, divide by 3, divide by 3. So now x is equal to 41. So that's your x, okay? Okay, let's try example number 10, 11, 12, I mean. All right, so let's look at this. Which situation is this? So I'm just gonna say one log, no log. That's a situation 1. Situation A. Situation B will be one log on each side. And then situation C will be multiple logs in one or both sides. No E. Both sides of the equal sign. Okay, so let's check. This is the equal sign. How many logs on the left side? 1, 2. And on the right side, you have 1. So you have 2 logs here. So this got to be situation 3 or type 3. type C, I mean, if you have multiple logs, you need to condense them because they are an expanded form, right? So I'm gonna give an example again. If it's a minus, that means these two needs to be divided. If it's a plus, this two needs to be added. Okay, sample time. Log 4, 5x over or minus log 4, 5 equals log 4, 2x plus 2 plus 4, okay? All right, so 1, 2, 2 logs, and then you have a minus sign, all right? Let's use a different color there. 1 log, another log, and then you have this minus sign. So that means you need to divide this 2 here, okay? So let's do that. I'm gonna copy log 4 first. We're gonna condense this expanded version, log 4, and then there's a minus sign, so that means it's gonna be 5x over 5. 5x divided by 5 equals only 1 log, so you just pretty much copy that. Okay, simplify this. So 5x over 5, that means 5 divided by 5, so that just means x. Okay, so therefore all of these is just log 4x equals log 4 2x plus 4. Okay, once you get to this point, then you have to think up again, is this situation 1, situation 2, situation 3? Well, this is going to be 1 log on both sides, so this is situation B. So that means they have both 1 log here, 1 log there. You can pretty much cancel that. Now you have x argument equals argument, 2x plus 4. Solve for x, minus 2x minus 2x. Now negative x equals 4. Negative x means negative 1x, so you can divide it by negative 1 on both ends. So x equals negative 4. Again, you have negative on your x. You will want to substitute that in here. Not there, in here, because this is the problem that I used. And if gave you an error, then that means that is not even a solution. Algebraically, it is just yes, but it's not going to give you a correct answer. But then again, I just made this one up, so maybe that's why, all right? I'm just making up some problems. So you should try it with this number 12. Okay, I'll see you on the last video. I don't know how to cancel this.